ఏం చెక్ చేయాలి? లాస్ట్ టైం ఎమ్మెల్యే నరసింహారెడ్డి వాళ్ళు అయితే టెస్ట్ పెట్టారు మ్యామ్. మ్యామ్ అదే తెలియట్లేదు. Let's speak. Let's speak. Let's speak. Let's speak. Let's speak. Hello Rohit, is my voice audible? 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 Rohit, please check my voice.
ఈయన మంచి ఇంప్రెషన్ ఈయన కదలేదు మనలాగా అదే అంటున్నా మరి.
Hello everyone. A very good morning to one and all. Before starting this session, let's start with a prayer song by our student Divyashri. Hello everyone. A very good morning to one and all. Before starting this session,
माझ्या व्हॉट्सअप एको
hello everyone. A very good morning to one and all. Before starting this session, let's start with a prayer song by our student Divyashri. Thank you, Divyashri, for the wonderful song. Myself, I Saptami, Assistant Professor, Department of CSE. On behalf of CSE Department, MLRIT, I cordially invite you all to this one-week faculty development program on machine learning in big data applications and security challenges, which was held from 24th April to 29th April. Firstly, I would like to welcome our chief patrons of this FDP, Honorable Chairman, Sri Mari Lakshman Reddy Garu, and our Secretary, Sri Mari Rajashekar Reddy Sir, and Treasurer of MLRIT, Srimati Mamata Reddy Ma'am. And also, I would like to welcome young Director of MLRIT and today's chief guest, Ms. Mari Shreya Reddy Ma'am. Now, welcome our patron of this FDP, our source of inspiration, Principal of MLRIT, Dr. K. Srinivas Rao sir. Let's welcome Dean of MLRIT, Dr. QSC Head, Dr. V. Radhika Devi Ma'am for this program. I welcome our motivator and co-patron of this FDP, Dr. A. Balram, Professor and Head of CSE Department. Now, I welcome our convener, Kiran, Assistant Professor of CSE, and co-convener, Dr. N. Sirisha, Associate Professor of CSE of this program. Now, it's my great pleasure to welcome today's resource person, Dr. A.P. Shivakumar, Associate Professor of CSE Department, JNTU Anantapur University. Finally, I would like to welcome all the coordinators, advisory committee, organizing committee, faculty members of various colleges, research scholars, and PG scholars. Welcome all. Now, I request Dr. Azira Kiran, convener of today's program, to address the gathering.
Honorable Chief Patrons of Technology College, Autonomous, Hyderabad, Sri Mari Lakshman Reddy Garu, Chairman, Sri Mari Rajashekar Reddy Garu, Secretary, Srimati Mari Mamata Reddy Garu, Treasurer, and today's chief guest, a young and dynamic entrepreneur, stuffed with a abundant skills of business and academia, Miss Mari Shreya Reddy Garu, young and dynamic director of MLRIT College, Hyderabad. Dr. K. Srinivas Rao Garu, MLR Institute of Technology College, Hyderabad. Dr. V. Radhika Devi Garu, Head IQSC, Head of the Department Computer Science and Engineering, Dr. A. Balram Garu, and co-convener Dr. N. Shirisha Garu, Professor, CSE Department. My coordinators, Dr. P. Chinnaswamy, Professor, Dr. B. Sanjay Prasad Rao, Professor, CSE, Itam Raj, Professor, CSE, Dr. M. Kalpana Chaudhary, Professor, CSE, and various heads of the department, and my dear colleagues and wonderful participants, a very good morning to all. I am Dr. Ajmera Kiran, convener of one-week online faculty development program on machine learning in big data applications and security challenges, being organized by Department of Computer Science and Engineering, MLR Institute of College, Autonomous, Hyderabad. Welcome you all to this program. At the outset, I would like to thank management, director for sponsoring and supporting these types of subject of the FDP will focus on fundamental concepts and techniques related to machine learning, deep learning, and big data security challenges. This program aims to provide hands-on experience and available tools, recent advanced research outcomes in machine learning and big data analytics. Machine learning in big data analytics is an emerging area of this training program will provide a platform to the researchers, industry experts, and academic professionals to share their research experiences in the field of machine learning and big data analytics. This training program will definitely help participants better understanding and master concepts like classification, regression, prediction. It also enhances knowledges in deep learning basics and statistical modeling. We have received enormous responses for this program. I bring to your notice that within one day of the opening of the link for registration, we have received more than 400 responses. Total number of registrations for this FDP is more than 1400. This has happened because of the reputation of the institution. The credit goes to management, director, and principal. Most of them came to know about this workshop just being browsing our college website. This is success saga of our institution. The resource persons for this program are drawn from reputed organizations like IITs, NITs, and state universities, and some IBM companies. Hope all the participants will be benefited out of the deliveries of during these 6 days of program. I sincerely thanks for giving this opportunity. Thank you once again. I am thankful to beloved Honorable Chairman, Secretary, and Treasurer and Director. Thank you.
Thank you, Kiran sir, for your valuable information on this FDP. Now I request Dr. A. Balram, HOD of CSC, to speak few words about the department.
Yeah. Honorable today's speaker, Dr. A.P. Shivakumar, Professor of CSC, JNTU Anantapur, respected Principal, Dr. K. Srinivas Rao, and management. Dear colleagues, dear participants, ladies and gentlemen, a very good morning to all. It gives me immense pleasure in welcoming all of you to the faculty development program on machine learning in big data applications and security challenges organized by Department of Computer Science Engineering, MLR Institute of Technology, Hyderabad, in association with Kotler and Computer Society of India. Computer Science and Engineering has started with UG program in MLRIT in the year of 2005 with intake of 60 and increased to 240 in 2013. The department also offering MTech program in Computer Science and Engineering from in the year of 2011 with the intake of 18, and also department is having Research Development Center under the supervision of JNDH. The department has highly qualified faculty with excellent research publications, research scholars, and well-equipped labs. The department has collaboration with reputed industries, research development organization, and also offers seminars, guest lectures, training throughout the year. This program could not have been made possible without management, Principal Dr. K. Srinivas Rao Garu, Convener Dr. Azmira Kiran, Co-Convener Dr. Sirisha, and Dr. Chinaswamy, and department staff. I hope that everyone would take the result of the program in improving the teaching learning process to the students and benefit to the society. Finally, I wish all 6 fruitful days of interesting and beneficial program. I warmly welcome you again all. Thank you. Over to you, Saptami.
Thank you, sir, for your wonderful words. Now I feel grateful to have the presence of our beloved principal, sir, Dr. K. Srinivas Rao Garu, to inspire the participants.
So thank you, Saptami. Am I audible?
Yes, sir. You
Yeah.
are audible.
So today's chief guest, Dr. Shivakumar sir from Anantapur, and all the delegates, management members of the college, students, and the staff of CSE and the staff of other colleges. So once again, welcome to this faculty development program on machine learning in big data applications and security challenges. At the outset, I must congratulate the Department of CSE for organizing this wonderful faculty development program. And the core members of this faculty development program, like Dr. Balram, Ajmira Kiran, Dr. Sirisha, Dr. Chinnaswamy, Saptami, and other coordinators who directly and indirectly in to bring this wonderful workshop in front of you all. So as Dr. Balram mentioned, is MLR Institute of Technology established in the year of 2005, and it has become autonomous in the year of 2015. So which is the youngest college to get the autonomous status. So not only that, in terms of research, in terms of consultancy, patents, so we are in the top 10 in particularly in Telangana. So coming to this workshop, a topic of machine learning in big data applications and security challenges. So, as we know, big data has become increasingly important in many industries, from healthcare to finance to retail. With the explosion of data, the need for automated data analysis has grown exponentially. So, this is where machine learning comes in. It enables computers to learn and adapt to new data without being explicitly programmed. As all of you know, machine learning is used to extract insights from large volumes of data, and it has become an essential tool for businesses and organizations. I think these workshop definitely help you to explore in all these areas. However, as we rely more and more on machine learning for big data analysis, there are security challenges that we must address. Right. So for that, the machine learning algorithms are vulnerable to a range of attacks that can compromise the integrity, sometimes confidential, the availability of the data. So I think this definitely will address all these security challenges in data explosion of data. The first challenge is the data privacy. I think this also will be get addressed in this workshop, faculty development program. So this machine learning algorithms require large amounts of data to be. However, this data often contains sensitive information about individuals, sometimes such as the health records or sometimes financial information. So I think this also will be get addressed in this 5-day workshop here. This data is not properly protected, particularly health record and financial information. So it can be stolen or it can be leaked and leading to a serious consequence individuals and organizations. And another challenge I could see is data privacy is one which we have already discussed. And the next challenge is data poisoning. Machine learning algorithms are vulnerable to attacks where an attacker introduces malicious data into the training data set. This can make incorrect predictions also. I think this will also be get addressed. For example, an attacker might introduce false data into a fraud detection algorithm, causing it to miss genuine instances of fraud. I think another challenge is also there in terms of security challenges with respect. So adversarial attacks involving introducing small challenges to data to cause a machine learning algorithm to make incorrect predictions. And finally, there is a challenge of model stealing. So there are various models that the machine learning architects will develop. So machine learning models are valuable intellectual property that can be used to gain a competitive advantage. Attackers may attempt to steal these models, either to sell them on the black market or to use them to develop. So to address these challenges, it is important to implement security measures at every stage of the machine learning process. This maybe includes securing the data, protecting the machine learning algorithms, and ensuring that the models are kept confidential. This can also be explored in this workshop. So techniques such as data encryption, secure computation, and federated learning can help to protect sensitive data while still enabling effective machine learning. So in conclusion, machine learning is a powerful tool for big data analysis, but it also presents security challenges that must be addressed. So by implementing appropriate security measures, we can ensure that the machine learning is used safely and effectively in a range of applications. I think Dr. Shivkumar sir is going to address you all on these challenges, and not only today and coming days also. It will be a more discussed more insights of machine learning. So finally, I thank Dr. Shivkumar sir and complete department of CSE, convener, co-convener, and all the core members of this faculty development program. So thank you, and this definitely will help you a lot for everyone over here. So over to Saptami.
Thank you, sir. Thank you so much for your inspiring thoughts. Now I call up Mrs. Vedavidya, Assistant Professor, Department of CSE, to give her vote of thanks for this inaugural session.
Good morning, everyone. This is Vidya from CSA department. I'm here to give the oath of thanks for inaugural function. First and foremost, I thank Honorable Chief Patrons of MLRIT, Sri Mari Lakshman Reddy Garu, Chairman, and Sri Mari Rajshekar Reddy Garu, the Secretary, Sri Mari Mamata Ma'am, the Treasurer. I thank our Chief Guest, Miss Mari Shreya Reddy Garu, the Director, MLRIT, for accepting our invitation and finding some time for this occasion for the despite of her busy schedule, and also offering them with all amenities which our prime needs to make this event grand success. We are very grateful to our principal, Dr. K. Srinivas Rao Garu, for his words, for his encouragement. And his guidance has always been encouraging. I thank him for his interest and continuous support. Thank you, sir. I would like to thank the Dean IQAC, Dr. V. Radhika Devi Garu. Thank you so much for your support, madam. We are extremely thankful to our head of the department, Computer Science and Engineering, Dr. A. Balaramagaru, who was named as the backbone of all our doings in the department. And we thank you for our motivation, for your motivation, for organizing this 1 week FTP, and for planning the resource persons. Thank you, sir. I would like to thank Professor K. Sai Prasad, HOD of CSC AIML. Thank you so much, sir, for your support for this FTP. I would like to thank the convener, Dr. Ajmiral Kiran, sir, and co-convener, Dr. N. Sirisha, ma'am, and all the coordinators of the workshop, Dr. P. Chinnaswamy, Dr. P. Sanjay Prasad Rao, Dr. Michael Preetham Raj, Dr. M. Kalpana Chowdhury. Thank you all for your support. My heartful thanks to the resource persons for accepting the invitation. Their presentation has enriched the participants of the FDP with knowledge and created an intellectual environment. I'm further thankful to all the HODs and the Dean who have been supportive for this workshop. Thank you very much. Let us learn from this FTP all the important topics of the machine learning. Thank you. Over to Saptami.
Thank you, Vedavidya ma'am. Now I request everyone, please switch on your camera to take the screenshot of this FTP. Please, everyone switch on the camera, please. Once again, I request everyone, please switch on the camera.
Teacher, this man. Teacher. Thank you, Jason.
Thank you, everyone. Let's start the session after 10 minutes break. Please, after 10 minutes, please, everyone join to this session. Once again, good morning to all and welcome back everyone. Welcome back to everyone. I'm glad to introduce today's resource person, Dr. A.P. Shivakumar, Associate Professor, JNTU Anantapur. He did his BTech from SVITS College under JNTU Hyderabad, MTech from JNTU ACEA, PhD from JNTU Anantapur in area of information retrieval and cross-lingual intelligence system in year 2011. Campus placed from JNTU ACEA in year 2003 and worked in PCS Mumbai, EMC2 Bangalore for 3 years. Out of intense passion for teaching in year 2006, joined JNTU Anantapur as assistant professor in Department of Computer Science and he was in various administrative positions like placement officer, additional controller of examination of JNTU University, officer in charge of hostels, nodal officer, and coordinator TEQIP 3 World Bank Funds of JNTU Anantapur College of Engineering, Anantapur. At present, he is a NBA coordinator of department. Executed 1 AICTE and 2 UGC projects. Around 90 publications in reputed international and national journals and conferences. 5 scholars got their PhDs awarded and 10 more working on PhD. He currently teaches in the Department of Computer Science and Engineering. His subjects of interest include data science, artificial intelligence, machine learning, data warehousing, and data mining. Recipient of Career Award for Young Teachers for the financial year 2013 to 14 with grant of rupees 1,50,000 by AICTE New Delhi. Also received Outstanding Faculty for the contribution and achievement in the field of cross-lingual information retrieval by Center for Advanced Research and Design, VIF, Chennai. Key instrumental in designing examination management software for autonomous colleges. Currently, the software is in live at JNTU ACE Anantapuram, JNTU CE Pulivendala, KSRM Kadapa. Given invited talks on interview skills, how to deliver speech effectively, inspiring and motivation, presentation skills, change a perspective in career, etc. at various institutes. I feel very honored to read this profile about Dr. A.P. Shivakumar, sir. It's a very great profile, sir. Now, I request Dr. A.P. Shivakumar, sir, to take over this session.
Yeah, thank you, Satami. Am I audible? Do I have to increase my voice? Is it audible? Sir, is it audible?
Yes, sir. Yes, sir. It is audible.
Oh, great. It was a nice inaugural. Thank you, Kiran, Chudi sir, and then Principal Srinivas Rao sir, and all those who are part of the inaugural team. So, and also the participants. Thank you very much. And thanks giving opportunity as a resource person for this FDP. And this brief, shall we proceed? Shall we proceed, sir? Shall I proceed, sir? Kiran, sir?
Yes, sir. Yes, sir. Yes, sir.
Okay. So I'll be sharing the screen, okay, and then let me know if it is. Is this screen visible to all?
Yes, sir.
So is this slides are moving? If you're able to
Sir,
see
no,
the slides moving?
No, sir. No, sir. Slides was not moving, sir.
Oh, one.
Sir,
Slides
please
are
put it in the presentation mode, sir.
I kept in the presentation mode. I'm sharing again.
Okay.
Are you able to see the slides moving now?
Sir, there is no. Now okay, sir.
Slides are moving?
Yeah, sir.
Okay, great, great. Thank you.
Thank you.
So all the participants, I hope you're all like faculty and some of you may be teaching this subject. And I'm sure you would have done your own contribution in this learning and then the way you did machine learning. As you know that it's a topic of ocean, like, so I request others to keep your phones mute. So as you know that it's a topic of thrust area and a topic of interest, and many of you would have done your own, many of you would have done contribution to this area, either through research or through teaching. The first thing, during the World War II, the first computer was invented. And, hello? Yeah. Yeah. So during the World War II, I request others to keep your phone mute. Those who are on. Yes. I request organizers to kindly take over, like, those who are not in mute, we can kindly make the mute.
Sorry, sir. Can you please repeat it?
So those who are on mute, kindly mute them, like unmute. Okay.
Sure, sir.
So during this World War II, the first computer was invented, and it was invented to crack the German code. Probably you know that there was a lot of war during the wartime. There was a communication happening, and to break the code, it was one of the enormous thing. And the father of this particular thing was Alan Turing. He invented this machine, and during that, in 1950, so there is one. He was written a paper, like, in the computing machinery and intelligence. And in this open words of his paper, he said, I propose to consider the question, can machines think? So this was a statement in 1950 with Alan Turing. Probably that time the statement maybe it's a bit shocking and surprising to the people around, but now probably things are changing. Probably we have to accept that this may be a correct statement also. Now, you know that where we are actually standing today now. So the previous all revolutions is basically the industrial revolutions. We had the human mechanical power, like we had huge bulldozers, machines, which are actually helping the mechanical load of the man to be reduced. Now we are in a new revolution. The new revolution is a second mission age. Now this mission age is basically going to expand our cognitive abilities, our mental power. Now the computers are not just replacing the manual labor, but they are actually replacing the mental labor. Now this is very important. That's where the Hughes we talk about this. So helping in a cognitive level, that's what we say. You know that probably this is a famous game, like something like AlphaGo. AlphaGo was treated to be Chinese chess, one of the toughest game, and no machine has beaten this particular game. Like, the machine has not beaten this particular. Now recently, probably we just came to know that how this the machine is able to succeed in beating this AlphaGo expert. Now, how could it do it? Because it is done because of the decades of AI research, a lot of research, maybe some years of AI research. And you know that the AlphaGo was trained to play this Go first by watching or tens and millions of the moves made by the human players. So it starts playing with the human players and then starts observing how these human players are doing. And then by playing itself, the millions of the games, and then it starts playing itself the millions of games. And this machine learning, what's happening is, it has a lot of, lot of compute, like machine is allowing with a lot of examples. It's learning with a lot of it. So every scene, every visual, every screen, what you see is one example for it. Now it starts learning for the data. So this is very, very important. That's what we are basically saying, that it's a knowledge that enables the intelligence. So, and the main crux is that how do you put this knowledge into the computers, and has been a challenge for the previous approaches of AI, and currently also this is the major thing which we are saying now. So probably having said that, so you may be thinking that we have done a lot of things. So what we are learned today is a lot of things we were learning. Uh, the other things what we are learning is basically a lot of things with the intuition. What I mean by observation. So sometimes we won't communicate everything verbally, but probably we have some intuition knowledge, some observation, probably where we are actually trying to learn. So with this, what I mean to say is that, is there, probably if you look at this figure, what is happening now, when we are actually started trying to imitating the birds have actually they fly, we were not successful. So in order to be successful, we were successful in designing this flight, not because imitating this human bird, but basically we were successful having known the principles of aerodynamics. So here what the crux we want to put forward is that, so is there anywhere, is there any policy, is there any principles, how we learn how this intelligence, is there any principles, how we can define this particular, principles, how we can define this one. So that's a major thing which we are trying to learn. A lot of research is happening. Just like the aerodynamics principles, we are able to do this extraordinary flights. Is there any principles of intelligence? Is there any principles of intelligence, so that, okay, defined formulas where we can say, okay, my God, this is how you can learn the intelligence.
Sir, you can't hear your voice, sir. Sir, we can't hear you, sir.
Hello? Hello? Hello.
Sir, tell me, sir.
Is it audible now?
Now it is clear, sir.
Earlier it was not there.
Yes, sir.
Earlier.
Yes, sir. Yes, sir.
Oh, you didn't listen any of the earlier slides?
No, we have listened, sir. In between 2-3 slides, you missed it, sir.
Okay, then let me go back. I don't know what has happened.
Yeah.
Sir, is the slides moving now?
No, sir. It's stopped.
Okay, probably I have to start again. 1 second. Sir. 1 second. Sir, are you able to see the slides moving, sir? Slides moving?
Yes, sir. Slides are started.
Slides are moved?
No, sir, not moving.
Okay, 1 second.
Yes, sir. Now it's moving, but slides are not started.
Oh, 1 second. Just help me to set myself. And then
Okay, sir.
I kept PPT mode. Is it in PPT mode now? And moving?
No, sir.
No?
No, sir. It's not in PPT mode. Please press the slideshow button.
Escape button. 1 second. Is it okay now?
No, sir. Screen sharing is stopped, sir. Yes, sir. It's coming.
Coming now?
Yes, sir. It's okay now.
Okay. I don't know where we missed. Just briefly, I'll say, what.
Sir, introduction to MRS.
Here we missed introduction to this one.
Machine learning. Yeah.
Somewhere here. Okay. So earlier slides covered. Okay. Anyway, to just to clear myself, we were talking about this slide. It was by the Alan Turing. In the year 1950, he presented a paper. This was the opening remarks of that paper. I propose to consider the question, can the machines think? So he is a famous person who has actually created a mission to break the German code during the World War II. And we talked about here in this slide, where we are actually standing today in this mission is, because now we were talking about the cognitive abilities, how the machines are actually replacing the mental labor. We were talking about earlier reducing the human labor, like the mechanical load, the JCBs, all these things. Now we are talking about decreasing the mental labor of the humans, so the cognitive abilities. And this was a slide I was talking about. This is related with the Chinese chess, one of the toughest game, which none of the mission has beaten. And this particular game is AlphaGo. It's called Chinese chess. We just seen that recently this is beaten by the machine, and this machine is able to go do this because it has started playing with the experts and millions of times, millions of moves, millions of learnings, and then it started playing itself. And finally, it could expertise itself, and then it has beaten this expert here. So this is one thing we were trying to say, that one is clear that it's a knowledge which is enabled in intelligence, and to put this knowledge into the missions, into the computers, that's been the challenge for approaches of AI. And the backbone of doing this particular thing is machine learning. That's what we say. So in order to do this, it is not enough it is not enough to trying to imitate what we have learned. That's an experience by the X-tree, that when we are trying to make an aeroplane, first humans started to mimic this, actually, how these birds fly. They created some thousands of structures which actually look like a birds, and then they tried and then failed, until unless the Wright brothers could able to understand it is not the point of mimicking the birds, but it is actually the policy of how best we can do, how best we understand the principles of aerodynamics. So when we are able to understand the laws of aerodynamics, then we are able to design this particular flight. In the same way, what is happening is that, is there anywhere, can we define, is there any principles for the intelligence? Just like the last aerodynamics, where we are actually able to achieve this design in this one. Is there any laws of intelligence? Is there any laws of intelligence so that we can design, or as a sort of mathematical formulas or the functions? So, but it's not a very easy thing. Why it is not easy? Because you remember, what mission is trying to do today is it's not the intelligence bit, even it's not what a 2 years baby is able to do it. What I mean to say that humans are basically learning a lot of things with intuition and observation. That's where the missions are actually failing. Now, the 2 years old girl knows exactly how to handle a coffee cup or how to handle a ball. So we have not taken any special classes for them, or no parents have taught them, but the girl is able to understand because of her the intuition or the observation skills. So this is where the mission is actually failing. And of course, there is a lot of research is happening onto this area. And with this, we understood that the backbone of this particular intelligence is a machine learning, which is actually cramming this intelligence to the machine. And where we are actually standing in this AI, today, that what are the different applications of AI which we are readily experiencing in our mobile phone. We have a Google Assistant. The first thing is the Google Lens, the computer vision technology, which is enormously, we were very advanced in this particular AI technology. The other is a machine translation. You can see the Google Translate is translating in 133 languages. Recently added another 33 languages into this whole. Now, how best it is trying to see if you can analyze how the translation happening over the years, but you could see that changes also, how best the translation changes are happening, how efficient it is bringing. So like this, another benchmark we are having is the speech recognition systems, the NLP, which is again a beautiful, the AI application where we are actually seeing how best it is trying to do the speech recognition process. And so there's some of the applications which are notable applications which are seeing. There are a lot of applications which, but this is something which is handy to understand. The machine learning itself. There are some different representation for this one. Some represent this entire thing as a database. Some represent this data science as a part of it. Yeah, but ultimately this is what we can understand: the data science, the machine learning, and the deep learning and the big data. Of course, we're all into this same domain. One thing we can understand. So the artificial intelligence, basically, we talk more into the artificial intelligence machine learning, and the artificial intelligence basically we talk about the searching and path finding. And the artificial intelligence itself has 6 domains. The domains we talk about: the NLP, we talk about the computer vision, we talk about the knowledge representation, automatic reasoning, the machine learning, the robotics. So the artificial intelligence is a domain into 6 domains, and in that, machine learning is one domain or a subunit. In this, we have something like the deep learning is also another subtopic of the machine learning. And when it comes to the deep learning, it is all like assumption, not exactly is an assumption, but because we don't have any proved theory how exactly the deep learning system is working, we only assume that we are trying to understand how the brain is functioning. We are trying to represent in a neural network form. So that's what we say as a neural network. We believe that this is how it is happening in the brain, but no, we don't have any concrete proofs for that this actually happening in the brain. So this is all about the deep learning. So basically, in the deep learning, we talk about 2 techniques, that is CNN and RNN convolution networks, basically used for the image processing. and very noted one for the images. So this is also another representation. We talk about the machine learning, the deep learning, and you know that data mining is also one of the cutting area here. Yeah, that one thing we have to understand, the data mining. Sometimes we also talk about this as an unsupervised learning also. Now most of things are merged, like we are learning as an overlap some lot of things. So we are learning data mining, sort of we talk about a lot of intelligent data, pattern recognition, how best we are trying to, we also learn about the clustering and all these things. So basically is a small definition, like, the science of making the machine smarter. That's what we say as the very quick definition. We talk about the artificial intelligence. So this is in human, we have the brain. In the same way, we use the artificial intelligence to make this computer robot, some machine, which simulates like human intelligently and ability to handle some of the main tasks. So before we go into this one, probably the three types which you already know, that's supervised learning, unsupervised, and reinforcement learning. But my presentation will be more of real-time examples. We talk about how best we can teach the student, how best we can teach this particular student. Now, if you remember, like this is the different, you can see some of the images on the screen here. So if you can observe these images, now you can see, you remember how we were actually taught in the schools. We were taught in the schools by a teacher. Like this is a pen, this is a cat, this is a dog, this is a laptop, this is a keyboard, and this is a slate, this is a duster. So we were actually taught each and every object, and it is taught under some supervision. So we were teaching, we are learning under some supervision. Somebody is actually supervising our learning process. He's actually talking about this is a cat, this is a dog, this is a laptop, this is a keyboard. And this particular process of learning, particularly basically we say as super learning. In this particular learning, we have the learning data. Now, if you can see this example, now we are trying to make the system learn that this is the data of a monkey. So this is the different, this is what we talk about. The other terminology we say label data and all. But I present in this different way, we have the learning data, we have a set of things, and we are actually making a model to learn that this is so-and-so object. And probably we are saying this is these are the monkeys. So this is this particular phase we are talking about, the learning phase, where we are trying to build a model. So in this, you may think what is supervised here? So the supervised here is that we know, see, as I told, this is a cat, you are saying this is a cat, and this is the duster, this is a duster. So you're showing this object and you're saying what it is. So this is a supervised because you know what actually you're learning. Monkey, that's what I'm saying. So in real-time world, what happens to this model? This model is nothing but a model with a lot of examples of the trained data with answers also. Now you have our data, we have a lot of example data, and this data is for what? And this data is talking about that. You have the input and you also have the output value also. And that input value and output value, what you have is actually your set of examples with the proper input and output values. And that values you are actually building and making a model. So this is the model, and this is a phase. We can see the dotted phase. We are talking about this particular thing as a learning phase, and this we talk about this. The other part we talk about is the testing phase. Normally, in our examples, we talk about dividing this data into 70%, 30%, and then okay. So that's what we try to do. But as overall, there's something like learning phase and the testing phase. And the testing, we are actually doing what is it. And then probably if you're able to say this is, yeah, of course, this is a monkey, then fine, well and good. Your model is doing good. And maybe, I don't know how much efficiency, it can depends upon how much efficiency you require. Then probably we'll test these models. And if it's not perfect, the model, probably you retrain this model and again, until you get perfect results. So now we are trying to build. So that's what we are trying to do. So we are trying to build with a lot of inputs and building, and then we are trying to build an example of an output. Now these are different examples. Like we have different databases, we have train input, and this is where we talk about the learning algorithm. And this learning algorithm, we try to build a model, and this is the model we are trying to build. And next time we'll be having user input, which is given to test this model, and we get this output. So this is how we say the supervised, one of the machine learning algorithm supervised. The name supervised here, we have to remember that it is happening under some supervision. So either it may be a teacher, or set of examples with the output. So because this is happening under some supervision, we say this particular thing as a supervised learning. So this is a lot of examples. We have the beautiful examples of supervised learning. We have very noted is a fraud detection. We have the email spam detection. We have the diagnostics, image classification. And again, we have the regression in the risk assessment and score prediction. Now, this can be taken another view of this one. These are the set of examples, and we are teaching what exactly it is, and then we are building a model, and the next time we are able to predict this particular. Another example, I was talking about the email spam detection. Now you have an email data set. The email data set, you have a lot of, so now you have in your inboxes in your email. I hope none of us have actually designed whether it is spam folder or we have not designed inbox folder or something. There's a Google automatically does this particular part. And another important is it has its own spam folder. And I hope like it automatically pushes this particular mails into spam. It identifies this as spam. Now, if you can see background, how it is actually happening. Now, Google has itself has the email database has a huge messages. We actually identify which are the normal messages and which are the the spam messages and ham messages we talk about. So we have the data of the normal messages. So we actually train the model. We actually train the model with the normal messages. So your model is built in a supervised model. Your model is built with a supervised learning where you have the data talking about these are the normal messages. And then your model is built. And next time a new message comes into the inbox, based on the model you have prepared, now this particular model is going to decide whether this particular message is a ham or a spam message. Let's take a simple example. Now you have a, normally in the messages, how do you decide this particular message is a ham message or spam message? One simple example, let's take you are an academic career. If your mail is getting with the message, the content of the message is basically talking about lottery, it is talking about prize, it is talking about money, it is talking about different events related to the financial aspect. Definitely that is not related to your domain. So that is how so it identifies, probably we have a set of, where we have identified these are the normal messages and these are the spam messages. So we train the model with the normal messages. So basically it uses this base classification algorithm. So the probability of the number of words. So if you take a new mail basis coming, so it tries to calculate the probability of the each and every word which is in this particular message. And it tries to calculate some of these particular probabilities. And then if you see the particular mail message, the number of words are more towards the normal messages than particular, we say this particular is in, as a particular ham message. We say ham is nothing but not spam. So spam is nothing but once we say has to be discarded. So once the mail comes to you, it calculates the probability of each and every word. What is the chances of this particular word to be in a normal message? It calculates the probability of each and every word, sums all the probabilities of each and every word, and then tries to say this particular, if the probability of this particular message being a normal message, the probability is very high, then we say this is a ham message. Of not, if it is spam message. So this is one of the best example which we say. The another best example is you have a true caller. Many of us are using this particular thing. Now, if you see this, now when you get a particular, it identifies this as a spam, call. Now, thing is, how does it identify? It is again by one time, like once it comes to it, ask whether it is spam. You yourself will be training some of the data for that. Yeah, it is a spam message in the sales. So like this, your each and every call is being trained that this is particular is a spam. Naturally, sometimes there may be chances that the it may be new call from the spam person, but first time it may be through, second time it may be through, but over the period of the time, as and when the data is improved for this one, it is learned, so it is told supervising so and so number is it is a spam, so and so number is a spam. And so the model is built perfectly, and whenever the new call comes, then it automatically identifies this as a spam message. It's like a normal how the messages are, how we handle this normal messages. Again, it has some set of data with the normal messages, normal callers, and the data with the spam callers, and it automatically identifies us. The beauty is that it gets updated and then it gets learned. It's a process of learning, and then it gets updating itself. So another best example of what we see is you all know is the credit card fraud detection. The best, you have a lot of data here, and then one best example how it is identified, trying to identify the credit card fraud detection. It analyzes all the transactions which is happening over a period of time and period duration by person, by customer, and all these things. Now you have a training data, so where you can see this is the normal behavior. This is how the normal credit card transactions has happened. And anything in abnormal which comes up, it's again, the model is built with that data. So what can be the data? A simple example, you have a lot of transaction data. Now, normally one person does shopping at one day, probably it ranges from maybe during festival times, it's okay, different, but normally the range is always normal. So if it is going abnormal, then this is out of this normal context of the spending and all. So then probably you have your model which is trained into this shows something different behavior, and probably we take it as a different transaction, it's a fraud transaction, something like this. So this is another best example how we are actually training this. Another thing, a lot of other data is there. One is the networking IP. It keeps track of this particular network IPs of all the people who are coming. Suddenly you get some different network IP and some different. That's also hint of it can be a fraud transaction. So this is another example. So another example, basically we have, especially diagnostics. The beauty of the machine learning, supervised learning, I always think it is more to it is not for the well-advanced countries, but it can be for the people, developing countries and low developing countries. Because the point we are talking about to cater the health facilities to the lower and lower levels is one of the toughest part. Let's imagine recently it is identified that the machine learning and AI system has identified 3 more cancer cells which were not found by any of the doctors till date. So they could identify that because of this historic data. Somewhere it was, it was clicked in, and this machine ability could learn. So I always believe the supervised learning model is best. It can cater the people of all people, because you have an expert. If you are having, probably you can have a best experts in the best countries, and it's not possible to take them to all. But if you can build a model, with expertise of all these people, like probably that knowledge you can bring it to you can make it useful to any of the places, isn't it? Suppose you have a checks expert, the moment he sees an X-ray, he identifies what type of disease you are having. Now you have built a machine learning model. You know that it can be always chance that you may see this particular new cases every time, a new case, but 90 to 95% of the time you have set up cases which is already coming. Now, if you have an expertise of this particular person and you have built a model, and then definitely you have the data which is whatever the credentials you pass through, again the machine learning model is able to identify whether this particular disease is there or not there. And we just seeing this particular thing in the COVID time also. So how best it is trying to do. Like this, there are a lot of applications of the machine learning. we just seen the number of examples. The one thing is that here everything is supervised. That means you have the data, you have an example data with what exactly it is and what is output of it. And you know what it is going to do, and you are building a model exactly with that data. So it's happening under 100% supervision. And normally these particular models are very, very efficient because these models are trained with all the successful data, and this efficiency is very high. That's absolutely correct. Now, in my introduction to this class, I was saying, yes. So in the introduction to this class, I was talking about like the beauty of this particular things is not this. We have long way for the machine to go, because I told that it's not always the supervised way we have learned. We have learned a lot of things in an unsupervised way. I told one baby girl is able to handle, she knows how best to handle a coffee cup. She knows how best to handle a ball in her hand. So it's all because she learned with an observation and intuition. And that is where we are lacking. That's where we say is something we say unsupervised learning. We have, as humans, we have learned a lot of things unsupervised way. Now, if you want to make this mission more intelligent, mimic the human behavior, then probably you should also have an capability and an ability to learn in unsupervised way also. And this gives a concept like learning in an unsupervised way. Now, earlier I told about earlier I told this is a cat. I told this is a cat, and this is a dog, this is a laptop, and this is a keyboard. Now I said this is a cat, you learn. Now what I'm trying to do in this particular unsupervised way, but I'm throwing this entire set of data, and throwing to the machine and say, now you learn on yourself. Now you learn on yourself. That's how the task we have given. Now, we have not told what this particular object at all. And then we are saying, now let's imagine that we are trying to build a model to identify the animals of a zoo. Okay, I'm trying to build a model like okay, I want to build a model with all the animals. I thrown all the animals, images of the animals in the world to the machine, and I said, okay, come on, you learn. Now, if I say this particular concept here, now if you can see that how exactly it is happening. So in the unsupervised way, the two things which we need to understand is something like, one is called exploring, is something like exploring the method with clustering. Another is extracting the values or the dimensionality reduction that we talk about. So exploring, what do you mean by this? So when you have a set of objects, when you have some set of objects, basically, now let's take a simple example of in this particular sort of an apple object. Now it's trying to, it is having an object, so it's trying to identify this the points here on the circumference. So this is also the points on the circumference of the glass. This is a point circumference of the vehicle. There's a point on the face. So how it is actually happening. Now, given an object, now suppose this is one object. Now, there are a lot of, in this image, there are a lot of objects are there. There's sort of an object like a sun, there's an object like hill, there's two more objects here, there's an object like a cloud. Now, what we are trying to do, we are trying to create these features for these particular objects. So we detect the objects and then start creating objects, the features for these objects. The objects, and now you take this particular one. Now let me take three parameters, three features I want to extract here. The three features are area, another is a perimeter, another is a skeleton. So here, if you can observe this, there are three objects. I'm trying to extract three features from this particular object. Now, once I extract these features, what I'm trying to do, I'm trying to group these features, group the objects based on the similarity of the features. Now, this is an area, this is a perimeter, and this is skeleton. So what I'm trying to do, I'm given an image, I'm trying to detect the objects. I'm trying to detect the... I request somebody is on unmute, kindly mute, please. I request the organizers to kindly mute the person who's on. I request the organizers to kindly mute the person who is on.
Sir, sorry, sir.
Somebody is actually on unmute. Kindly mute him, like it's a disturbance to the class.
Sir, unmuted, sir. Muted, sir.
Muted.
Thank you, sir.
Okay. Still some noise is coming. Still somebody is on. Organizers. Hello.
Sir, it is better to lock the participants.
Sir, 2 minutes. Yes, muted, sir. Muted.
Okay. Oh,
Yeah.
yeah. Okay. So in a previous learning, we actually told that this particular object is what. So cat. Okay, I told this is a cat, and then you learn. But now in this particular example, you're actually not saying anything about the object. You're just throwing this particular object. Now this is the image which you have thrown to this one to the machine to learn. Now how it is actually trying to do, it is actually trying, if you can see this particular image, now you have some lot of objects into this one. Imagine this is, again, probably you can take any of the image like this. Okay, now you have a lot of images. So in the same way, if you can take the one of the features, maybe I talk about area, perimeter, skeleton, something like that. What I just take these 3 parameters for all these images. For all these images, I'm just trying to extract these 3 features. The area is what, the perimeter is what, the skeleton is what. And based on these features, now what I try to do, based on the feature similarity, I group these particular objects, I group them into particular pixel. Now imagine this is an object, like if you can see this object, apple down here. Now suppose you are throwing a bunch of apple images and bunch of glass images. Based on these 3 features, I'm actually identifying, you look at these 2 images at the down, apple and then a glass here. Based on these 3 features, one is the circumference, one is on this, one is the area and circumference and the skeleton. Based on these 3 particular parameters, I'm actually able to differentiate, or I'm able to classify these 2 objects into 2 different groups. Hope you're getting my point. The point here is that, so earlier we were clear about what exactly we were learning, but here we don't have any learning inputs. Basically, we've thrown the images, set of images, and we are trying to learn. The machine will do the process of exploring this data, exploration of this data, and it explores the data, and it creates a set of features for each and every image, and based on the similarity of these images, it actually creates into the different groups. So one thing you may ask, the other point I just want to say, that it can be, the images can be fractional also, in the sense, what I mean to say, suppose if you are able to identify this particular glass, now the set of these features, it is also identifies the bigger glass also, because these properties are the fractional properties of the previous glass. Understood? The area will be in a fraction, the perimeter will be in a fraction, and the skeleton will be a fraction. So it's like it's something like a 2x4 or 1x2, the same thing. So this is one important point. So what we are trying to do, we have an input data, and this input data we are making into extracting into the different features. Based on the feature similarity, we are trying to group this particular into some different groups. Now we have this input data here, okay, and this is what we are seeing now. Exactly, you can see the difference here. Now you are actually trying to say earlier notation, and say earlier you are actually showing this particular apples and saying these are the apples. Come on, model, you learn it and say once this particular object is given, you say this is an apple. Now in the unsupervised model, you're actually given some set of input data, and this model is basically, it is actually creating some features based on similarity. It is actually grouping them into one particular group, and this is made into another group. Now this is a main difference. Now this is a major how actually internally this supervisor and unsupervised is working. And then of course once you show the model, then it identifies because you have features. Now same like this, a model for the unsupervised one, you can, if you show an apple object, then it will identify, okay, this is an apple because it has grouped the images and it is studied, and the set of group will have some features. It will learn from that group. So this is how we have some examples here. So different examples. The same thing, we can have unlabeled data. So interpretation, the processing, it identifies outputs as the dogs and the cats. So one thing, it is clear that the unsupervised learning algorithm, definitely one of the best and efficient algorithm, because here it's not possible in a life that to have always a supervised learning. It always a lot of things we come across as an unsupervised learning. So this particular, but the efficiency level, if you see, definitely the supervised learning will have a high efficiency compared to this unsupervised learning. But practically the model of unsupervised learning itself, it's unique, and then in real time this is more feasible and then possible. So this is one of the DB scan clustering algorithm, how it does like clustering into different clusters. So a lot of things, how it identifies the different objects, looking at whether it identifies whether it's a police car or the normal car and all these things. So the different objects, different features. So the lot of applications we talk about, one important thing is the text mining, the face recognition, the image recognition. Yes. And then, of course, it is more used in the clustering. The important concepts is more used in biology. The city planning is, So, then targeted marketing. So one image, or the face recognition is a well-known app, and then text mining is also one of the important applications in the unsupervised learning. Then, having known this supervised and unsupervised learning, so let's talk about another form of learning, that is, let's imagine, if you want to play this chess game, now you already have the two learning algorithms. One is a supervised and unsupervised learning algorithm. Then is there any need for this reinforcement learning algorithm? That's the first thing I just want to derive. Is there any need to have a reinforcement learning algorithm? Now, if you ask this point, let's design this particular playing of the chess with a supervised learning algorithm. Now, suppose now you have set of you have white and the black side. So now let's take the first move yours. First, you pick your Sipahi, and then 2 steps ahead. Either it can be any of the position. Like this, start defining each and every step. Like suppose if he brings this Sipahi, then what step you are supposed to do, like this. Now, practically, is it possible to imagine every step, what can happen at this particular time? And again, it is respect to all the movements, all the positions of the board. It is really impossible. You never know what the different position it takes in the different time interval. So it is not at all possible and feasible to design this particular, in order to play chess. It is not possible to design using the supervised or unsupervised learning algorithms. There should be a different way of where it can a different way where it can handle this particular gaming part, especially. And that particular thing we talk about is a reinforcement learning algorithm. The reinforcement learning algorithm, there are 4 parameters we talk about normally. It is a reward, punishment. So there are 2 important words. So what we do, very simple, this particular object. Now, all of you remember how we learned cycling. If you remember how we learned cycling, definitely it's all about the trial and error. The 4 terms we always talk about in this reinforcement learning algorithm: trial, error, reward, punishment. Something. These are the 4 terminologies we talk about. So if you remember how we learned the cycling part, once we come into the, all of you had experience of how you learned cycling. So we never learned in one go. We had so many falls, and then with a lot of experiences. One simple example: suppose parents may help to one extent. They may hold the cycle at the back for some time and then leave us. And then once they leave, they only think 2 things which to us they say us to keep the handle straight, and then whenever you fall down, then start applying the force. So with the pedal, something like that. No, but they never talk. They never say like how much is the intensity, the velocity, the acceleration, direction you have to keep, and all these things. No, they never say that. They only say these 2 parts and then leave us. So in the same way, but how we learned is all basically with a lot of trial and error. Now, suppose you're in a bit falling position and you apply a lot of pressure, then you learned, okay, if you are in this particular falling position, you apply a lot of pressure, you're up. So that's what. So you did some trial and then you learned, you learned, isn't it? So in the same way, basically this particular reinforcement learning is basically, it does a lot of trials and a lot of tries. And the one beauty of this particular thing is that every time it does some try, it has something, and it is going towards the positive, going towards the success. It remembers this particular path, okay, and sees that it is doing this particular one again and again. Now, let's imagine that you are playing this particular game. See, sometimes we talk about this particular reinforcement algorithm. The rewards may be immediate. Some of the things will have a rewards very immediate. Some of the rewards will be very immediate. Some of the rewards may be, suppose if you are playing a ping pong game, the ping pong game is a very small game, and then immediate, it has an immediate results. So you can very immediately you can have a results. But if you're talking about like chess game, so the chess game, the reward may be at the end of the game. Let's take a simple example here. Suppose you're trying to play this game here. Let's imagine it's a tree of from move. You always take the tree. Imagine it's a tree. How we go ahead, entire structure. Suppose if you start moving from this direction and then you start playing good. After some time, and you see that you have lost the game. Now, if you backtrack this particular how actually it has happened back, then you can imagine something, a structure like this. You can see this particular structure with a list of probabilities coming to the end. So you're coming to the end result. And then when you win this particular game, then probably you understand, you increase the probabilities of the curve, which is actually given to the positive results. Or else, if you think that in anywhere in the path of this particular curve, you had a loss of the game, then what we try to do, we just go back and then decrease the probabilities of this particular curve. Now, in other words, what is trying to happening? So every time we are moving towards a success, we increase the probabilities of this particular route. Every time we see that there is a failure, then we try to decrease the probabilities of this one. Imagine that this is happening it is playing for some, not just for 1 or 2 games, but sometimes it may play for years also, in order to get all this, for every, because this is one branch which is happening for one game. Imagine that this game played over millions of millions and millions of millions times, or the millions of the people, and sometimes some years together. Then what all the different moves it can do, what all the areas it can fail. Suppose there is elephant here and there is Sipai, this is the position, and then you have done one step here from here, and then that has made into checkmate your game. And next time, whenever you're in this elephant, there is Sipai position, whatever the move you have done this time, you will never do that because the probability curve of this particular is very high that you fail into checkmate. So you take another route. You take another route and then come back to learn this particular route. Like this. So every time you have a positive reward, so you keep on, updating your branches, and then so like this, it starts playing with number of times, and then that's the game of this particular AlphaGo we are talking about, isn't it? This is also the best algorithm we talk about. Let me say this is the best algorithm for training a robot. The robot, the tracking of the robot, let me show that. Yes, I stopped. I'm sharing one video for you.
Okay.
So I just want to show one practical. Now you're able to see the YouTube. Now you're able to see that?
No, sir.
No? YouTube?
Now I can see, sir.
You're able to see that?
Yes, sir.
Okay. Now, yeah, this is a mini cheetah, the robot, how it plays a football. Now, if you can see this, how it is actually trying to learn. So now this, it's actually learning. It's trying to learn its experiences. Yes. Now this is the point I just want to say here. Now, if you can observe, it does with a lot of trial and errors so many times. The cheetah is actually is able to talk. This is an algorithm of the reinforcement learning algorithm. Now it does a lot of trial and errors. That's what I just pause at this particular steps. So now it does one move and then it failed down. It's again a try. So again, whenever it comes to that position, now it has dropped. Now it has failed down. Now at what position it has failed down, it has the data for it. Then next time when it comes to that position, probably it will not do the same step again because it knows that it has fallen here. Now see this part at this point, it says, this is how, yeah, that's what. Now it's cleverer and getting cleverer every day. They experience the model, how it is getting experienced. So it's with a lot of trial and errors. So this is the point I just want to say, that in the same way how it is actually playing with a lot of chess game, it's a game how it is playing with a ping pong. Let me show another game for you, another link for you. This is also one of the game how the system is actually getting better. One more link for you, I'll share with that. 10%, that's like okay, this is so this is a game for, yeah. So you're able to see this game, ping pong game, which I'm able to see. You're all able to see that? You're able to see that? No?
Yes, sir. Yes, sir. Yeah.
Good. Now, again, this is, if you can see this one, this, let me showing this in YouTube. So how this, you're able to see this deep reinforcement algorithm on the screen now?
Yes, sir.
Okay. Now this is, now we are trying with the reinforcement algorithm. Now see this, how it is, after having trained for 25% of the games, the probability of success, how it is varying, so it starts learning in itself. Now you can see that it is, because see, every time whenever it had a fail, then probably it will remember that this is the path which has given to me fail. Now after training 5,000 episodes, the success of this particular game goes by 95%. And now how the success has varied, you can see that the same game. Now imagine that this particular relay, when it's going this particular position, it faces this problem. Next time, whenever it comes to that position, it won't do that. It won't do that. It will do on another way. And suppose the success rate of this particular thing is very high, then probably it remembers that. So this is also another thing. But I told you, but it's not so it was so it was not simple. Like it's not faster, because sometimes we are talking about sometimes it will take some years also to make master itself. That's very important. Some years also. There are some games which is to get into the master, it will take some 100 years also. So that's again disadvantage with the reinforcement learning algorithm. That's where when we go to the deep learning, so what's actually we are moving to the deep learning, again what we see in the disadvantages is reinforcement, then we go to this one. Now this is a simple opening a robot which is trying to open a handle, and it is being trained for 1 hour, and then different permutation combinations, like different success. So if you can see this one, you're able to see this robot opening a handle, opening a handle. You're able to see this? Yes. Okay. So these are the two difficulties we talk about. So yeah, rather, this how the reinforcement learning basically it works. It's what we want to say. Where am screen? Yes. Go back to this presentation. So I'm back to the screen. PPT, is it, you're able to see that? Back to the PPT?
No, sir.
Okay. Now, that's what I'm trying to say, that just like you have seen the cheetah, like you have seen the Pac-Man game, you can see the ping pong game. In the same way, we can simulate this particular chess game also, how the reinforcement learning algorithm. So you can imagine that there is a branch of...
Excuse me, sir. We cannot see the PPT.
You cannot see the PPT?
Yes, sir.
I shared.
No, sir. It's not on the screen.
Even I cannot see.
One second. I don't know. Let me share again to you. Share. Okay, now you are able to see.
No, sir. Now we can see.
Okay.
Okay, sir.
Yes.
Yes, sir. Okay.
Great. Yeah, this is what I just want to say here. So the reinforcement, basically, it is trying to just imagine that each and every game, each and every, even you take about cheetah, what has happened. just imagine that it is at this point of the node where it is fallen. Now, next time when it comes to this particular node, it will take another branch. Okay, it will take another branch and goes, and then probably just imagine there are a lot of branches for it, huge tree and number of branches, and every branch is nothing but one particular move it does, and every move will have some 4 or 5 steps. After 4 or 5 steps, it is able to stand and then do it, then increase the probabilities of this particular branch. And next time when you come to that particular position, then you have to take this particular branch, because the success of standing is very high, the success of winning is very high, then probably you have to take this branch. When you go down this branch for 10 nodes, again there may be 2 more branches, and again in the 2 more branches, one may lead to success, one may lead to failure. Like this, you can imagine the ultimately you will get one set of a set of graph, or imagine some with set of probabilities for each and every step you have taken, and then ultimately. So that's how the cheetah is trained in. We have around 37 cheetahs in the market, which is very famous. And the Boston cheetah is one of the world famous cheetah. And you can also see the MIT cheetah is one of the beautiful thing. You can the way they train this cheetahs, the way they train this particular models is very beautiful and excellent. I just always have an intuition to leave you not just with a simple learning of unsupervised, supervised, and this algorithm, but I just want to give more, maybe a brief why we actually went to the deep learning system. So before that, maybe this is a simple diagram where we have some supervised and supervised dimensionality prediction. This is another thing. That's where we are talking about. And a lot of other, there are a lot of applications. But those who are teaching AI, if the student is shown with a lot of examples, like, so because it's an online, we are not showing so many videos of it, but a lot of videos, especially you can make one set of video with all stuff where you want to show. It is into different agriculture, and we have an agriculture robots, we have the ones we are with pesticides. These are the robots which are transportation robots, inventory management robots, and very famous, the autonomous cars which we have, the self-driving cars, the Waymo, the Tesla, and it's also into this one. It is actually done one of the complex heart operation also. And the hazardous environment, we have the Mars mission and exploration into the oceans. We have the personal robots.
441.
Hello. So we have the personalized robots also, the personalized services. This is very trending in US market now, because many people are, I request one of the participants kindly mute your phone, please. So this is the personalized services. The one in the robot is it's a cleaning robot. So it's very famous, available in Amazon for 27,000, something like that. Entertainment robots, we have human augmentation and all this. Now the point is having idea on the supervised learning, the unsupervised learning, and the reinforcement learning. Why do you need deep learning? That's a question. Why you need deep learning? So when you have a supervised, when we are learning about unsupervised learning, supervised learning, it's a very standard one. That's how the teacher has told. But we said no. It's not always a supervised learning. We have to have unsupervised learning also, because as humans, that a lot of things I've learned with an observation, and a lot of things I've learned with without any teaching. Then I said, okay, oh my God, I want to make a mission like a human. Then I also need an unsupervised learning. Okay, having learned the supervised learning and unsupervised learning, then why did I go for the reinforcement learning? I told the specific examples of playing the game. Or let's imagine the another example. Okay, now you take this particular world. Now suppose you want to, like another example, we want to do sometimes the real-time scenarios. One example I'm missing here, but yeah. So there are a lot of examples where it is not possible for us to write with a supervised and unsupervised. You cannot, write a supervised learning algorithm to how to play chess. It's not really possible, because you cannot expect what are the different permutation combinations which can go happen here. The only option is that it is the best is that so machine starts playing and learns with trial and error. It's not no rule as such. So this is how you got reward remembered. Then they go in this particular way. That's it. So this is but having learned these three algorithms, what is the need for the deep learning? So this deep learning is basically, if you can imagine, this is the human cell and what we have. And then probably we try to create a function. We are trying to create, this is one cell. So this is one cell, f of x is one cell. Okay. And then you are passing some inputs and then you are getting an output, something like this. And same thing, we are trying to put one or two cells. So you have some one or two cells like this. Now in the deep learning network, all these circles are nothing but the cells, just like what we have in the human brain, the different cells which are coming algorithm. What we have seen, we have extracted the features. What we have done, we have extracted the features. So based on that, we have some trainable classifier which are built model. But in the deep learning systems, the extractions are not just in the feature extraction. We extract the features into different categories in hierarchical fashion. We extract the low-level features, we extract the middle-level features, we extract the high-level features, and then we build this classifier. This is a major difference between the deep learning network and the traditional feature extraction networks, either it is supervised or supervised, whatever it is. Now, when you have deep-level features, the mid-level features and high-level features, the efficiency of this particular model is very, very, very high. See what happens if you extract a feature and if the model is not, then probably you have to again extract, re-extract the feature and then build the model. But here there is no scope for it because we are doing in a phases and in a hierarchical fashion, how we are extracting the low-level features and then the middle features and this one. So even in the pure machine, the RL algorithms, we are talking about the best. So the pure RL algorithms also in too many trials. So it's not possible because see, sometimes it is told like there are some missions which will take some 250 years to 300 years. Virtually, suppose if you are trying to learn this, this is an autonomous car, it is trying to do with the RL algorithm. Is it possible? No, probably you have to crash some thousands of vehicles for every trial and error. So everything you do in the real-time world, probably it will kill you. So there should be a very efficient, that's what we talk about. Let's try to understand with simple example for all of you. So let's imagine that there is how actually the deep neural networks is going to work. So with this small example, we'll try to wind up. So this particular thing, now you have some set of messages. Hi, Yusufa, hello, LAN, meeting at 4 p.m. Yes, I'll see you in the conference room. Now, you have represented this into hierarchical fashion. And this particular vertex, in this particular hierarchical one, you're trying to learn the edges. And the second, you're trying to learn the strokes and the characters, the meaning and everything. What I mean by that. So in the first phases, if you look at the 4 p.m., like you have so many edges here, 1, 2, 3, 4, 5, 6. Now in the first layer of your deep learning network, probably you're trying to learn the edges. In the second layer, probably you're trying to understand the strokes. And next level, you're identifying this exactly the character. And the second, another layer is basically you're trying to understand the meaning. And next layer, it is actually trying to understand the high-level meaning of exactly what this message is actually happening. That's what we actually believe is happening in the human brain. Now, human brain, we think that there are some different cells which are connected. It is into this pattern. You can see this. Now, this is a point. This is a point. Now, this is a point where V1, and this is a point where we are actually trying to learn the edges at this particular point. And the next is a V2. This is a point where we are actually learning to find the small shapes of it. And the next is a V4, place where we are trying to get the parts of this object of it, something like that. Now, we only believe that this is a passion. This is a passion, how the human brain is built, and then how it is learning in a passion. So you may say how without exactly knowing how it is happening, we are trying to build this one. But only thing, because see, I'm able to achieve a lot of results. I'm getting good results. So that's the reason we always assume that this is how it is happening, and then we are proceeding. But to say exactly, we don't know how it is actually happening inside the brain. That's for sure. In the same way, now what we are trying to do, we are trying to one particular pace. We are trying to create the edges, trying to learn the edges and the strokes and the characters and the meaning, and then high-level meaning. So this is how one deep learning network is trying to understand this high-level meaning, breaking this into so many hierarchies of learning. This low level is nothing but the low level features of it, the middle level features of it, and then high level features of it. And then we are trying to identify. Let's imagine there is a tire. Like if you have a tire, now if you can see this, this is you have different tires. You have we talk about MRF. We talk about Apollo tires, something like this, cellulose, something. So Bridgestone. Now, if you can see these motifs inside this structure, now you have a tire, but how actually the patterns inside this one? Now this is looking sort of a leaf, and inside the leaf there is some sort of a zigzag shape. Can you see? This is the first image. Now go to this one deeper. This is another pattern. This is another pattern. This is another pattern. Now this is how the deep learning networks. It goes to the very, very minute details of the object. But whereas the same thing, if you're trying to learn with a supervised learning algorithm, unsupervised, it is a feature, tire. It will take as a tire, as a feature, a tire. But it is not going into the deeper of what tire, what model, what structure it is having. Because it's not extracting the low level, it is only extracting the tire features. Now, if you take the overall car, like it may extract the overall structure, the tires, something like that. So this exactly the difference, what we always talk about. The one beautiful particular, this network is always the deep learning network. The important feature we talk about is the backtracking. Is one of the important features of this particular thing. What do you mean by this backtracking? Is basically, we are. So this is one of the important point. The beautiful of this supervised algorithm and unsupervised algorithm. In this supervised and supervised, we have a network, we have a model built, and the model is giving an output. Yeah, once you check your output, then the output is wrong. Then what we say, the output, most of the time output is wrong. Then we go and build the model again from the starting, from the scratch. But here, the one beauty of the deep learning network is that here we have something called a back propagation. In the back propagation, we actually trying to create the loss. And then what is the loss? What do you mean by loss? So you have trained a model to identify the pen. That's the same thing. So you identify to train, or you build a model to identify the monkeys in the supervised learning algorithm. Yes, I built a model to build monkeys. I built a model with the deep learning network, but it is showing, instead of monkey, it is showing some other object or some small mismatch of that. Now what I do, I just do the back propagation and I correct the parameters which is actually giving this particular thing as a wrong for me. That is the beauty of this particular deep learning network. Anyway, we are not, I'm not into this deep learning. I just want to say my comparison that if you have a supervised, unsupervised, and the reinforcement, how it is important that we are going to the deep learning networks. The only difference we should remember here is that in this particular network, we have the feature extraction. But the deep learning network, we are talking about more into the features. Yeah, here also the feature extraction, but the feature extraction is happening in a hierarchical fashion, where it is the features are extracted in the low level, middle level, and then higher middle level, then the higher level. The another important feature of the deep learning network, in our traditional supervised model and all, once we have the extracted model and then we have built a model and we check the output, if there is a wrong, then again I have to do this one. But in the deep learning network, here we have an important concept called back propagation. where I can just go and adjust the parameters, which is actually giving me the correct or wrong, whatever it is. So that exactly the difference between the three machine learning algorithms and then the deep. So this is again deep into this deep learning network. So so I hope my my point, like why we need this supervised, why do we went to unsupervised? If you have a supervised and unsupervised, why we have learned on reinforcement learning? If you have the supervised, unsupervised, and reinforcement learning, why I went to this deep learning network? So my point is only that I just want to prove that why I just want to throw light on this particular areas. With this, I think this is the topic given to me is basically the introduction part. So I believe that this concepts would have helped you to understand what is a supervised learning and what is unsupervised. If you have supervised, why we haven't done unsupervised, and if you have both supervised and unsupervised, why we haven't done reinforcement learning, and if you have this supervised and unsupervised reinforcement, how it is different to the deep learning network. I'm hope that this concept would have got some idea to you. Is Kiran sir available? Kiran sir is there? Any of the organizers are there? Any of the organizers are there?
Yes, sir. Yes, sir.
Okay, okay. Yes, Saptami ma'am. So we are, I just coming to end, like, the concept introduction to the machine learning. So thank you very much. Thank you for giving this opportunity. And any doubts, you can ask me anything related to this concepts I told. Any of the participants, you can also text here if you want. I'm happy to answer you. So I know these concepts will be mostly looks basic, but the way I have done an interpretation, because I always did with the comparison. So I always thought of because most of the time we know supervised, but why do we need this? We know unsupervised. Why do we need this? It's in comparison. It makes best to present to the students. So that is how I just want to give inputs into this one. Okay. Yeah, thank you. Somebody was saying, hello?
Any queries from participants? Can you please ask?
Sir, if possible, can you share the PPT, sir?
Yes,
Madam,
see.
chat box few queries is there, madam. Suggest some resources on reinforced learning.
Yeah. Where is the question? Like some resources. Okay, okay. See, this as per this information world, probably there is a standard book on reinforcement learning. Currently, I can't suggest you, but I can text you. Especially for the reinforcement learning, we have one famous book on reinforcement learning. But as such, what I define is that the ones the standard textbook, the Russell we have. So probably if you can start with that, and then a lot of resources on internet also it is there. So as far as the information is concerned, now we are all living in information world. It should not be a problem. And semi-supervised, of course, see most of the models what we are building is basically semi-supervised. As you know that sometimes there is a data which is available, which we can train and supervise, and the rest will be the unsupervised. So it's all semi-supervised models. Because as such, we cannot have a completely supervised. Sometimes we have a data, we train it, and the remaining we'll ask the machine to learn itself. So something like that. Yes. Okay. Okay. Yeah.
Any other questions from participants? We will share all the materials about the all sessions. Don't worry about the materials and PPTs.
Oh.
No questions from the audience.
Yeah, somebody's asking.
Okay.
Hello, sir.
Yep,
Sir, I'm Dr. Dunstan Rajkumar from VIT University.
great. Yeah,
I'm from Department of Commerce.
please, sir, please.
And throughout the session, it is very simple to understand being the person from Commerce.
Oh,
I'm really thankful to Dr. Sivakumar sir and organizers.
okay, sir.
Sir, I did my psychology also.
Okay, great.
I'm easily able to understand, and the metaphor that you have given for associating that artificial intelligence and machine learning
Yeah,
with the help of the very lucid examples.
yes, sir, yes.
Sir, we studied about that reinforcement learning into positive and negative.
Yes, sir.
And
Yes.
you are talking only about the positive alone, or what about the negative sides of the reinforcement learning?
So you mean to say what are the negative effects of reinforcement learning, or positive and negative you're talking about? Yes, sir. You are talking about like in the concept you all learned positive and negative. That's what you're
Yes, sir.
talking.
Yes, sir. Yes, sir.
That's what we are defining with a punishment and reward.
Yes, yes.
Positive and negative. So there is nothing like a negative. So if it is
And whenever you're going for trial and error, and you're learning the positive sides.
Yeah.
And
So,
what about the
so let's imagine this is a curve. Now, when you are at this point, when you get a positive curve, you will take like this. Now you remember that this is a positive curve. So next time when the machine is here, then it will take a decision to go to the positive direction. So this is a path which will increase the probabilities of, okay, there is a success chance of this branch is very high. Now imagine that earlier, like before coming to this conclusion, there may be chances that it has taken this branch and it has failed here. What will it do? It will increase the probabilities. I mean, it decrease the probabilities of going this particular case. So the probability here is 0.8, probability is 0.6. So it will go to 0.8 because the probability of winning is high. So let's imagine the two probabilities is 0.8 and 0.8 at this point. So when it fails here, it will decrease the probability to 0.6. Again, it fails 0.5, 0.4, 0.1. So 0.5, 0.5, 0.8. It will go into this positive direction because the winning is very high. Like that. So it keeps on updating the branch of the probabilities. Wherever there is a success, it increases the probabilities. So next day at that node, it will take which path it has to go. So based on so it keeps on updating the probabilities. Is it clear, sir?
thank you, sir. And from the supervision, unsupervision comes. And from the unsupervision, the reinforcement comes.
Yeah.
And from that, you've gone for deep learning.
Yes.
So we need to then look at all the supervised, unsupervised, and reinforcement as deep learning covers everything.
Yes, sir. See, now the supervised, unsupervised is only for some set of data, sir. 100 data, that's it. Now we are all into deep learning systems. In order to handle the huge data, it's only the deep learning networks we are using. This is only for the small data, not for the huge data. So as a real time, we always use for the deep learning networks. Because
thank you so much, sir. Thank you.
Thank you, sir. Thank you. Okay.
Is there any queries? Final call for queries.
Madam.
Okay, sir.
Okay.
Shaktivel, sir.
Ma'am?
Sir, go ahead, sir.
Madam, my ID was missing in the list, madam. Last shared finalized list, ma'am.
We will share.
We will share, sir. We will share.
Okay, ma'am. I have attended the session. Then fill the attendance link also, ma'am.
Sure.
But ID was missing. Kindly check it, ma'am. Okay.
Okay, okay, sir.
Thank you.
No, thanks for present. Sakti ఎవరు చూడండి పంపించారు
Thank you, sir. Thank you for sharing your knowledge and expertise today. Your session was so empowering to all of us. We look forward to have more sessions with you in the future. Once again, thank you, sir. Thank you very much. Dear participants, thank you very much for joining today's session. Hope you all acquired more knowledge from this session. Let's all join together in the afternoon session at 1:30 p.m. Have a happy learning.
Sir, thank you, sir. Shivakumar, sir.
Thank you very
Yeah,
much.
thank you,
And,
sir.
Okay, sir. Thank you.
Nice meeting.
Madam, organized, madam.
Sir,
Ma'am, you are giving the schedule from 2 to 4 and we have planned up to 2.
yeah, sir. Actually, resource person had some work, so he's coming before half an hour, sir. He requested to start the session before half an hour. So that's why I mentioned the time as 1:30.
Because I have class, I have preponed the class during the lunchtime. Then I wanted to attend.
1:45 will start.
Okay,
That's
sir.
why.
Then 1:45 will be started recording all his queries.
Sure. Thank you, sir. Thank you.
Okay. Participants, we have shared the attendance link in the chat and also group WhatsApp group. Also, there is the attendance link, so you can go through that link and give the attendance. Thank you all. We are going to sign off. Yeah, you can exit. you.